Let us obtain a Fourier series to represent fx equal to x minus x square in the interval minus pi comma pi, and then deduce that pi square by 12 equal to 1 by 1 square minus 1 by 2 square plus 1 by 3 square minus 1 by 4 square and so on. So, we want to obtain a Fourier series for the function fx equal to x minus x square. Now, Fourier series to a function fx is actually an infinite series given by fx equal to a0 by 2 plus n goes from 1 to infinity an cos nx plus bn sin nx. Here fx is equal to this, of course there are other factors like convergence, but what we need now here is we need to determine those coefficients a0, an, bn. Now a0, an, bn is given by the formula an equal to 1 by pi integral minus pi to pi fx into cos nx dx, and bn is also equal to 1 by pi minus pi to pi fx into sin nx dx. Of course, we need to determine those an and bn. Here fx equal to x minus x square, a0 equal to 1 by pi integral minus pi to pi fx dx. That is equal to 1 by pi integral minus pi to pi fx equal to x minus x square. So, x minus x square dx. If you integrate x, you will get x square by 2. If you integrate x square, you will get x cube by 3. Lower limit is minus pi, upper limit is pi. So, this is equal to 1 by pi, pi square by 2 minus pi cube by 3 minus, we write, so these are upper limits, and lower limit minus pi square is same as pi square. So, pi square by 2 minus pi cube, and then minus will make it plus pi cube by 3. Now, 1 by pi is there here as well. Observe that we can cancel something. Pi square by 2 minus pi square by 2, we can cancel it out. Pi cube, there are two number of pi cube. So, this is equal to minus of pi 2 pi cube by 3 into pi, and that is equal to minus of 2 by 3 into pi square. So, we have determined a0. Now, let us determine an. Again fx equal to x minus x square. Therefore, an equal to 1 by pi integral minus pi to pi fx. Fx is x minus x square cos nx dx. Let us evaluate this. So, if we want to find this value, we have to calculate the integral. We want to calculate the integral x minus x square whole thing into cos nx dx. Of course, n equal to 1, 2, 3, 4 and so on. Now, it is a product of two functions and one of them is polynomial. In such a case, it is much easier to calculate using Bernoulli's theorem. What exactly is Bernoulli's theorem? Integral of u into v dx equal to u into first integral of v minus u dash into double integral of v plus u double dash into triple integral of v minus and so on. Once again, u into first integral of v, u dash, the derivative of u into double integral of v plus u double dash, double derivative u into triple integral of v. Let us write one more term, u triple dash into fourth integral of v, plus so on, plus minus plus minus. Observe that u is a polynomial of degree 2, so u cube will be 0, so we don't have to compute those. Therefore, integral of x minus x square into cos nx dx equal to u is x minus x square, v1 let's write integral of cos nx, let's write it later on, minus u dash, derivative of x minus x square is 1 minus 2x into integral that we can write later on, plus double derivative, first derivative is 1 minus 2x. If you differentiate it, x minus x square 2 times, that means you will differentiate this one, derivative 1 is 0, derivative minus 2x is just minus 2. Triple derivative, we don't have to differentiate it because derivative minus 2 is 0, so we don't have to write it. Now v1, integral of cos nx is sin nx by n. v2, double integration. So integral of sin nx is minus cos nx by n, but we have one more n here, so n square. Again, third integral, if you integrated cos nx, you will get sin nx by n minus as it is, sin nx by n, but we have n square as well, so n cube. Of course, you will have some constant of integration. So we have calculated integral of x minus x square into cos nx dx, but we want an, so that is 1 by pi integral minus pi to pi. Therefore, an equal to 1 by pi integral minus pi to pi. So we have to just put the upper limit and lower limit. First, let's write the expression x minus x square into something that we'll write later on, 1 minus 2x into something that we'll write later on, minus 2. 1 by pi outside the bracket, x minus x square into sin nx by n, 1 minus 2x, minus and minus you can write it plus here, cos nx by n square, and then minus minus plus, so we can write plus here as well, sin nx by n cube, and our limit minus pi to plus pi. Observe that sin n pi is 0 and sin of minus n pi is also 0. So this is when you write the upper limit, you get sin n pi equal to 0. When you write upper limit, you have 1 minus 2 pi cos n pi is equal to minus 1 to the power n, 0 plus cos n pi is minus 1 to the power n by n square. Sin n pi is 0. What about lower limit? 1 by pi as it is. This is 0. 1 minus 2x. You write x equal to minus pi. So 1 plus 2 pi. Whole thing into cos of minus theta is same as cos theta. So minus 1 to the power n by n square. Sin n pi is 0. Okay, let's simplify this. For simplifying, we'll take 1 by pi common. When we take 1 by pi common and then 1 by n square also we can take common, then minus 1 1 by pi we take common, 1 by n square also we took common, then minus 1 to the power n also we can take common. So, we are left out with just 1 minus 2 pi here, minus 1 to the power n, n square pi we have taken common, here you have minus 1 minus 2 pi. So, 1 and minus 1 will get cancelled. So, this is equal to pi will also get cancelled, minus 4 by n square into minus 1 to the power n, minus 4 by n square into minus 1 to the power n. Well done, we have computed a n. Let us compute b n. Again, b n equal to 1 by pi integral minus pi to pi f(x), f(x) is x minus x square into sin nx dx. So, let us compute the integral x minus x square into sin nx dx by Bernoulli's theorem. We compute the integral x minus x square into sin nx dx. First expression as it is, x minus x square, then integral of sin nx that we can write later on, minus derivative of x minus x square is 1 minus 2x, then double integral of sin nx we can write later on, plus double derivative of x minus x square is minus 2, then integral of triple integral of sin nx. So, first integral of sin nx is minus of cos nx by n. If we integrate it once more, you have minus of sin nx by n square, and then once again if you do it, you will get cos nx by n cube. So, that is we have integration. Therefore, bn equal to 1 by pi. Now, we just need to put the upper limit and lower limit minus pi to pi. So, let us write it. First, we have x minus x square as it is, minus of cos nx by n, that we will write later on, minus of 1 minus 2x, then minus of minus will make it plus, so we can just write plus, then minus 2 into that we can cos nx by n cube, that we can write. So, x minus x square whole thing into cos nx by n, then minus minus plus 1 minus 2x sin nx by n square, minus 2 into cos nx by n cube. Once again, limit is from minus pi to plus pi. Now, when we write x equal to pi, then you will get lots of expression. Pi minus pi square, minus we can write here and make it plus, cos n pi by n, cos n pi by n. What about this one? This one is simply 0, minus 2 into cos n pi by n cube. That is the upper limit we have completed. What about lower limit? Minus 1 by pi. When you write x equal to minus pi, you will get minus pi, and when you write x equal to minus pi whole thing square is again pi square, minus of cos n pi Sin n pi is once again 0 minus of 2 cos of minus theta is same as cos theta. So cos of n pi by n cube. Oh, observe that we can cancel something. Minus 2 cos n pi by n cube minus of minus 2 cos n, so that gets cancelled. What about other expression? Let's simplify it. We take 1 by pi common. We take cos n pi by n also common. Cos n pi by n also common. So when you take cos n pi by n common, you are left out with just minus pi plus pi square. Here you have minus 1 here, minus into minus plus, again minus, so minus pi, and then again minus minus plus, so minus pi square. We can cancel pi square out. So this is left out simply minus 2, because 2 pi by pi is 2, minus 2 cos n pi by n. So we have computed a0, an, bn. Let's write Fourier series. Therefore, Fourier series is given by fx equal to a0 by 2. What is a0? Where is a0? Minus 2 pi square by 3. Minus 2 pi square by 3. a0 by 2. Minus 2 pi square by 3 into 1 by 2. a0 by 2 plus summation of n goes from 1 to infinity an cos nx. Let's recall an is minus 4 by n square into minus 1 to the power n. So minus 4 by n square into minus 1 to the power n an cos nx, cos nx, plus n goes from 1 to infinity, bn is minus 2 by n, minus 2 by n, cos n pi is minus 1 to the power n, sin nx. Of course, fx equal to x minus x square. So we can write x minus x square equal to, we can cancel 2 out, minus pi square by 3 plus n goes from 1 to infinity 4 by n square into minus 1 to the power n plus 1 cos nx plus n goes from 1 to infinity 2 by n into minus 1 to the power n plus 1 sin nx. But the question is saying something more. Question is asking for alternating sum 1 by n square. What is that value? That is possible if this were some number and this were also some number. So we take the simplest number, take x equal to 0. Take x equal to 0. So 0 equal to minus pi square by 3 plus cos 0 is 1. So simply n goes from 1 to infinity, cos 0 being 1, 4 by n square into minus 1 to the power n plus 1, sin 0 is 0. Let's take this quantity to the left hand side. So pi square by 3 equal to, let's expand this sum. 4 by 1 square minus 1 to the power 2 plus 4 by 2 square minus 1 to the power 3 plus 4 by 3 square minus 1 to the power 4 plus 4 by 4 square minus 1 to the power 5 and so on. Now take 4 to the left hand side, so you'll have pi square by 12 equal to minus 1 square is simply 1, so 1 is by 1 square minus 1 by 2 square plus 1 by 3 square minus 1 by 4 square and so on, and we are done.